This video is going to provide an introduction to finding and interpreting slopes of linear equations. So I'm going to start by defining slope, and we use the letter M to stand for slope. Slope gives a measure of the slant or the steepness of the line. For example, if this was a hill and you were walking up it, the slope is telling you how steep is that hill. We define slope to be the rise divided by the run. So that means as we move from one point to another on the line, the rise is how much do I have to go up, and the run would be how much do I have to go over. In the example that I have drawn, to get from the point 1, 2 to 3, 3, my rise would be I'm at y equal 2 and I have to go up 1 unit to get to 3, so rise is 1. But from x equal 1 to x equal 3, I actually have to go over 2 units, so my run would be 2. That makes my slope 1 over 2, or 1/2. We can also define slope as the change in y value, that's how much we go up, divided by our change in x value, how much we go over. As a mathematical formula, that becomes slope equals y2 minus y1, that's the difference in the y values, divided by x2 minus x1, the difference in the x values. And so with this formula at the bottom of the screen, we can just take the 2 points given and plug them in to get our slope. I can let the point 1, 2 be my x1, y1, and I'll let the point 3, 3 be x2, y2. Turns out it doesn't matter which point you make point 1 and which point you make point 2, get the same answer either way. But using this definition, plugging into my formula, y2 is 3, minus y1, which is 2, so 3 minus 2 is 1. 3 minus 2 is 1, that's my change in y. And then x2 is also 3. x1 is 1. So 3 minus 1 is 2. And that's another way that I can get that slope of 1 over 2, or 1/2. So let's find the slope of each line. In my first example, I have a picture of a line. I can tell that this line goes through x equals 0, y equals 4. And it also goes through the point x equals 6, y equals 0. So I can use those 2 points to find my slope. I could plug them into my formula, or I could count boxes and think about the rise over run. I could also use a different point on the line. You can actually use any 2 points on the line. I chose 0, 4 and 6, 0 because they were easy to see. But if you look closely, this line actually does go through the point x equal 3, y equal 2. So I could use that point as well. And I can pick any 2 points on this line. I'll get the exact same answer. It doesn't matter which 2 points we pick. Okay, so if we want to think about this in terms of rise over run, to move from the point 0, 4 to 3, 2, we have to go down 2 units and to the right 3. So my rise would be -2, because that was down 2, and my run would be +3, to the right 3. So my slope is -2/3. We could have also used the 0, 4 and the 6, 0, and we'll get the same answer. Notice in that case you would go down 4 units and over 6. So the rise would be -4. The run is +6. And that also reduces to -2/3. -2/3 is my slope. Finally, a third way I could find the slope is I could just use my formula. Slope is y2 minus y1 over x2 minus x1. And so if I pick the point 3, 2 as my number 1 point, x1, y1, and I pick the point 0, 4 as my second point, x2, y2, then the change in y would be 4 minus 2. 4 minus 2 is 2. And the change in x would be 0 minus 3, or negative 3. And that gives me the exact same answer, negative 2/3. Finally, one last way we could have done this, that rise over run, if you started at the point 3, 2, you could have gone up 2 and to the left 3, and that's kind of what happened in this computation. The rise is positive 2, the run is backwards 3, so negative 3, and that still gives me my same slope, negative 2/3. Here's another one. This time we have one of those kind of special cases. We have a horizontal line. It's actually the line y equals 3, horizontal line. If we want to find the slope, we can actually do the same thing we did in the previous problem. We can pick any 2 points on that line. So I'm going to pick the point 0, 3 and 3, 3. I just randomly chose 2 points on this line. One thing I notice about this line, because it is horizontal, the y values are always going to be the same, always be 3. So using my formula, change in y would be 3 minus 3, or 0. The y values aren't changing on this horizontal line. My change in x is 3 minus 0, or 3, and 0 divided by 3 is 0. In fact, a horizontal line always has a slope of 0. You can think of it as a flat ground that you're walking on. There's 0 slant or tilt to it, so the slope is 0. What if we have a vertical line? In this case, this would be the line x equal negative 2, because the x's are always constant. I'm going to pick any 2 random points on this line. I'll pick the point negative 2, 0, and negative 2, 2. But I could pick any other point. The idea being every single point on this line has an x value of negative 2. So this means when we compute our slope, our change in y, 2 minus 0, and our change in x is negative 2 minus negative 2. 2 minus 0 is 2 minus 0 is 2, but negative 2 minus negative 2, minus a minus becomes a plus. Negative 2 plus 2 is 0. The run, the change in x is 0 because the x values are constant. And 2 divided by 0 is actually undefined. We can't divide by 0. So our vertical lines, those are like cliffs. They are infinitely steep, and so we say that they have an undefined slope. That's going to be true for any vertical line. Let's run through a couple more examples. Find the slope of a line that passes through the points 4, negative 3, and negative 2, 1, negative 1. We don't have a picture this time, but we can just directly apply our slope formula. I'm going to make the first point given my y1 or x1, y1, and the second point x2, y2. So plugging those into my formula, I'm going to take y2 minus y1. So negative 1 minus negative 3 divided by x2 minus x1, negative 2 minus 4. Minus a minus becomes a plus, so negative 1 plus 3 is 2, and then negative 2 minus 4 is negative 6. We are going to reduce this fraction. 2 divided by 6 reduces to 1 over 3, and the answer is negative. So my slope would be negative 1/3. Here's another one. Find the slope of a line that passes through 1/2 1 and 3 2/3. Same process, but the math is going to be a little bit harder just because of the fractions. But I'll call that first point x1, y1, and the second point x2, y2. I'm going to take these numbers and plug them into my slope formula. y2 minus y1 is 2/3 minus 1. x2 minus x1 would be 3 minus 1/2. 2/3 minus 1 is negative 1/3. And let's see, how did I get that? 2/3 minus 1 over 1. You need a common denominator. So the 1 over 1 turned into a 3 over 3. 2 over 3 minus 3 over 3. 2 minus 3 is negative 1. Denominator stays the same. So I got negative 1/3 for my rise. 3 minus 1/2. That's 3 over 1 minus 1 over 2. We need a common denominator, so I'm going to take the 3 over 1 times it by 2. That gives me 6 over 2 minus 1 over 2 is 5 over 2. So now I'm left with negative 1/3 divided by 5/2. And I'll just rewrite that using the division symbol. We've got negative 1/3 divided by 5/2. To divide fractions, we copy dot flip or multiply by the reciprocal. So I copy down the negative 1/3, change to multiplication, and I flip the 5 over 2 to 2 over 5. Now I can multiply straight across. Negative 1 times 2 is negative 2. 3 times 5 is 15. And there is my slope, negative 2/15. One last thing I'd like to mention about our answer is notice that we got a negative slope. And what that means, anytime you get a negative slope, it means if you read the graph from left to right, it's going down. It's decreasing. So negative slopes means you're going downhill. Positive slope means uphill. Again, if you read it from left to right, going uphill. And then finally, we already learned that zero slope would be flat. So that's something to keep in mind if you're trying to interpret your answer. And in fact, let's actually take a look at an application problem and see if we can interpret what exactly is slope telling us in a physical context. And the answer is slope always gives us a rate of change, how a quantity is changing. And so let's try to understand this by just looking at an example. The problem says, a researcher is conducting an experiment on a bacteria colony to test the effectiveness of a new antibiotic. 3 hours after administering the antibiotic, the population of the colony was 11,500. 2 hours after that, the population was 9,250. Find the slope of the line connecting the points 3, 11,500. So that first point represents the 3 hours. Population is 11,500. And then we've got the point 5. 2 hours after 3 hours is 5 hours. 9,250. So for the first part of this problem, we're just going to compute slope. And this is something we already know how to do. It doesn't matter that it's a word problem. We can still use our same slope formula. Slope is change in y over change in x. So I'll take y2 minus y1 over x2 minus x1. So 9,250 minus 11,500, which is negative 2,250, and then over 5 minus 3, which is 2. And if I do the division, I get negative 1,125, negative 1,125. So the negative slope tells me that my line is decreasing, going down. In the context of this problem, that means the population of the bacteria is decreasing or going down. And we can see that with the numbers. You got 11,000 something, and then 2 hours later, it's down to 9,000. And so that's why our slope is negative. That population is declining. And in fact, that slope is giving us a rate of change. It's telling us how quickly is the population decreasing. How steep is the line? How quickly is the population decreasing? And in fact, part B asks us to write a sentence to interpret slope as a rate of change. And so to do this, I always like to attach units to my slope computation, and that really helps me get my sentence together. So when we computed slope, we took that 9,250 minus 11,500, and those numbers represented our population of bacteria, or number of bacteria. So we took a population number on top, and then the 5 minus 3 was time in hours. We divided it by hours. So the units of my slope is number of bacteria per hour. So my slope, negative 1,125, is measured in bacteria per hour. And so what this slope is telling me is it's telling me how much, by what rate is this bacteria decreasing per hour. The negative means decreasing. So I'm going to describe my slope as the bacteria population was decreasing at a rate of 1,125 bacteria per hour. So again, slope gives us a measure of rate of change. In this case, we're working with a population, so it describes how the population is changing with time. All right, that is my last example on this video. We're going to continue to talk about lines in our next module and the next couple videos, so we'll get a lot more practice with the concept of slope moving forward.